Hello everybody, welcome to Romi Lesson 5. Today we're going to be going over motors, servos, and joysticks. I'm going to briefly go over joysticks, but for the Romis you don't really have to use them because we're just using the keyboards. It's going to mainly be servos, and I'm going to show you how to do at least the first part of the project. And then the motors part I'm going to briefly go over as well, because you should be able to figure out how to do it just by what I kind of tell you what to do. So we're going to go to here. So motors, servos, joysticks. When we're using the FRC bot, we're going to be using a lot of motors. And usually we don't use arcade drive or differential drive like we're using with the Romis, where we just have but sometimes it's 6 wheels on that thing where we just go forward and then we turn by moving these wheels in opposite directions. The big bot, we have something called swerve drive, which is a lot harder to program. And the wheels can move on their own. They kind of have their own minds, and they move based on where they're positioned and where the joystick is pointing. So it's a lot better, it's a lot faster than this kind of simple movement system, but it is a lot harder to program. So we're using arcade drive now, so it should be pretty simple. But yeah, we're using also pneumatics. We haven't used that for a few years, but that's just basically we pump air into some tanks, and then we use that air to do useful work. So maybe moving a robot up to a secondary position, like lining it up for the shot, or even climbing maybe we could do pneumatics for, but they're actually pretty easy to program. They're just using solenoids and digital signals, so they're not too bad. 1 or 2 servos. I think we use a servo. It's very useful to know because servos, you can go to a precise angle, which is super useful for a lot of different situations. If you have like little game pieces and you need to open like a little door to move them in, or maybe you just need some high torque servos that do like a little simple thing, they're super useful. So it's good to know. But all these methods should be in the Romi example code that I gave you. This might be outdated. We're going to take a look at it today. But you can set the degrees from 0 to 180. This is how you do speed. This is also, I think, outdated. I think this is right. Joysticks. I usually use the Xbox thing, which has its own library, so we're not using like generic code. So like get raw access, it would be like get left joystick X or get left joystick Y, instead of just get raw access, because X is on 0 and Y is on 1 or something like that. So we probably won't do that, but I'll show you briefly how to put it in the code, so when you go to that bot, you'll know kind of how to do it. But it is a little bit different. So that should be it. So your goal is to spin a motor. So we'll talk about that really quick. We'll go into the code here. Okay. I'll just get rid of my little example code so I can do it with you guys. But let's go to our subsystem. Let's go to drivetrain here. And you'll see in here we have 2 motors, and these are your left and right motors. We got left motor here and right motor here. Your current drive thing that you call to move the thing is called arcade drive, and it's actually using arcade drive in here. So you give that x-axis speed and z-axis rotate. For this one, I want you to create a new method, so a new public void method that just takes in like the speed for whichever motor you want to rotate. Could be left one, could be right one. And then you're going to say instead, I'm going to put it in this one just to save a little bit of time. We're going to be using not the encoder, but the motor. And then if we go back down here, we put a dot after that, and then I want you to pick one of these things to make it move at the speed you want it to. So that's what I want you to do for that one. But let's also talk about joysticks really quick. If you're going to be doing, let's say you create a controller. So let's go into here really quick. Just ignore this. I'll keep this for when we need it. But let's say we have a joystick here called mController. And if we want to use that, we can bring it down. Controller.get. And then you pick an axis. And this is how you get it. You call it, using a little bit different thing, and then you put new whatever in there. Syntax for that is in the thing, but you'll be using the controller, and you'll be getting like get axis or get magnitude is also pretty useful. So if you want to call something when you move the joystick like maybe to 30% out, that's pretty useful. Get raw button, you can get all that stuff. You don't even have to declare a button if you don't want to. I just kind of like to because it's a little bit easier to read. But you could just get raw button and then put this number in here instead. It's a little tip. So let's talk about servos. Just because that's kind of the main thing I want you to focus on right now. The motor things first, get that done. That should be pretty easy. And then the servo thing's a little bit harder. So let's go back to our thing here. So we want to write a command to move a servo to a position when you press a button, and a different position when you press a different button. Okay, so we need to figure out where our servo is declared first, like what port is it on. And we're going to do that in the subsystem, okay? And this isn't the right code. And that would be in the onboard IO subsystem because we have a servo right here. And I'm going to just get rid of all of this. And we'll also comment that out. But the way we're going to hook up a servo, I should probably get one for you really quick. I'll be right back. I'm going to go grab one. When you are hooking up your servo to the Romi, it's not on the board like everything else we've been doing. Like the motors are integrated onto the board. I mean, not really, but they're attached to it. And the LEDs are on the board. But this is actually an off-board component. So you'll ask me, once you get to this step, just ask one of us to give you one of these, and we can give you one. And you'll see on it there is some wires coming off. So these wires right here, make sure you can see this. So we've got a brown, which is ground, red is signal, and the orangish slash yellow is 5 volts. So if you look at your board here, I'm actually going to open up this thing. Actually, let's go to Romi board. This is in the classroom page. I wrote down all of your pin numbers and everything that you need for the code. But we're going to look at this really quick. So this is on the Romi Web BI, which I'll show you in a little bit. But if you look at the little headers on your Romi here, this is the same exact thing. So the black on there is ground. The green is 5 volts. But if you can see really closely, I have a little jumper on my thing. That just connects the bottom pin with the middle pin. That's what the red on the screen is. That's a jumper. It's basically a wire that connects those two things. So this 5 volt is only on this pin here. And then when you jump it over, it connects to all of the green ones. So the whole thing here is 5 volts. And then the blue is the signal. So it doesn't quite line up. Actually, I think I have I can't remember which ones are here. But the blue is your signal pin here. So that correlates with this. So if you connect to your Romi, which I'm going to do now. I'm just going to connect to it. I don't know why. So we're going to be using something called PWM control, which is basically how we control a servo. So the servo can go from angles 0 to 180, and maybe these are SG90s, which are micro servos. They're pretty tiny. Like there might be a smaller version, I don't know, but this is the smallest I've seen. And you put like a little thing on there, and then you can turn this. This is not the greatest servo. Oh, there we go. But it spins about that much. And the way you do that is through PWM control. So on the Romis and on the Robo Rio, we're going to be sending signals to this. And in your code, you're going to have to declare what kind of like what's the low for PWM and what's the high for PWM. But PWM is essentially a fake analog signal. So right now we have digital signals. I think that's what we've been mostly using. We have, except for maybe speed for the motors. But we've been using 0 volts and 5 volts. So 0 is off, 5 is on. But what if we want like 2.5 volts or like 3 volts or something? There might be some pins on here that can actually produce like a static 3 volts. It might be a little wavy, but it's nearly static 3 volts. But it's actually a little bit simpler to just create something that mimics 3 volts. So instead of having, this is a really weird, this wouldn't actually happen, but let's say you have your pin on for 3 seconds and then off for 2 seconds, okay? That would be a duty cycle of about like 60%, right? And duty cycle is just how much it's on compared to like how much it's off. So if you're on for, if you're going for 3 volts, that's 60% duty cycle, okay? So you're just turning it on and then turning it off. This would be 50% because it's on 50% of the time on a 1 hertz frequency, so it's a second. But that's what all this is. So if you want it for, if you want it for 0.1 speed or like 10% on, 10% brightness, whatever you need, you turn it on, then turn it off for that amount of time, turn it on, turn it off for that amount of time again. And if you do this really, really fast, like super high frequency, you basically get an analog signal. I don't know the exact frequency that these things can go on, but it's pretty good. So that's how you control it. So maybe like we're sending a signal of 1,000 milliseconds, and these are low duty cycles. And then that's the minimum, and then the maximum would be 2,000. So we're going between a range. And then there's a little board inside the servos that determines what angle that is based on our signal pin that we're giving it. But let's connect to our Romis so I can show you how to use the Romi web UI. Can't remember what the URL. Oh, here it is. So this is, you're just connecting over a local network to the Romi. So you got to be connected to the Romi to use this. But you're going to open it, and it's going to open this cool little page here, and you can see all of your Romi stats, your CPU usage, your network, memory, whatever you need to. I never really used it, but in here is where you're going to define. So you go to Romi, you go down, and this is where you make your pins what they are. Make sure you have this piece in here. I think I was wrong before. I think the yellow one is signal and the red one's power and the brown one is ground. I'm not 100% sure on that, so double check. We'll find out shortly if this works, but we'll figure that out. But EXT0, that's the one closest in to the Raspberry Pi, so it's like that pin there. EXT4 is this one out here. And what we can do is we can tell the Romi what thing to use. So there's analog in that could be used for sensors. DIO is digital input output, so it's digital like 5 volts, digital 0 volts. And PWM is what we talked about, that controls servos and maybe like a speed controller. And we can tell the Romi which one to do for that port. So you go to writable. Mine are all set to PWM because I wasn't sure which port was which. But you can go to writable and then change it, pick your thing, save to external I/O configuration, then go back to read only. And that's how you choose it. And it'll also tell you which port to do. So if I set EXT4 to DIO, I set this one to DIO and go to writable. It's now digital 8. So that's the number you'd use in the code. Cool. So and you can also calibrate the gyro, which I've already done. You can also hook up. This would be a really cool little project if you wanted to set up a little camera with it. I tried to do it, but it took a little bit too much time and just couldn't figure it out fast enough. But that's how you set up PWM on pins. Our next step is to actually do it in the code. So now that we've hooked up our servo, so remember, I know the brown one's ground. So we just hook that up to whichever pin you set to PWM. Alright. And you might feel that the servo is now rigid. Don't snap it like I just did, but if it's rigid, that's kind of a good thing because it's on at least. So let's go to our code here, and we know we can set the servo to whatever channel we are. So I set it to 6, which is ext4. Okay. Now we can go to robot container. Let's actually create a command here. And this command is going to tell our subsystem what angle to go to. So we can call this whatever we want. We'll say servo move. And we're going to set it up to where we want to take in onboard IO because that's the thing we're using. Onboard IO. We're going to create our local variable. Just do that. And then we'll create a global variable. Alright. And then we'll just set them equal to each other. You know the drill. And add requirements. Make sure you get that done. So it'll work. Oh, it imported the wrong version. Make sure you get the correct one, subsystem. So in execute, let's call, we're going to set this to true immediately. And we're also going to make this an advanced commands because I want to import angle. So we'll do double angle. Yeah, and we'll do onboard IO, not onboard IO, sorry. Double, I'm going to call it G angle, global angle. G angle equals angle. I should put that before add requirements. Doesn't matter, but it looks nice. Okay. So now we're taking in an angle, and we're going to want to also take in. There is a way to control the servos using speed in a direction instead of just an angle, which you can play around with. I'm not going to make a little thing about it, but if you want to take in speed, you can take in speed here as well. We're going to be using s_onboard IO, and we're going to be using the servo thing in there, and we're going to be giving it G angle, so it's perfect. And then it's going to end. Okay, so that's a basic command we just set up to call servo. And servo is using servo move onboard IO. Servo is using set angle, so if it's set, that's not quite right. It's a little bit different, but do set angle. And then we're also going to put in here set bounds from microseconds. And this is the one I found works best for the SG90. And this is just doing that the PWM thing that we talked about. So it's setting the minimum PWM signal for when it needs to go to 0 and the maximum for when it needs to go to 180. And that's what that is. So don't worry about that too much. That's just what it is for this servo. If we're doing the more beefier servos in there that you want to make a project for, I can get one of those out, but you're going to have to tweak these numbers just a little bit. I just found these on, I just looked it up in Google and I found a website that told me this, and it worked. And I'm also printing out set servo 1 to degrees, and we can put a space there so it's not connected. So that's what servo is. That's what I set up for that. Just going to quickly power cycle this so we get it working. So that's our pretty basic command. Let's go to robot container. I'm going to set up a few different buttons here. Let's just make these all like this, because you can set up 3 buttons, one for 0, one for, I just picked a number between those, and one for 180. I did call it servo move, so servo test, and then make sure you import your command to the top. I'm going to delete this because it doesn't exist anymore. And make sure you declare your buttons up here. And once we connect to the Romi, we can test this out and hopefully it works. But you are going to be responsible for doing the other spin around. You did the spin around one already. Just make sure you do the motor move one, and then the joystick. I don't think I have anything for that, but if you want to do that, I can set it up for you. Okay, try this out, see what happens, see what breaks, and then see if we can fix it. And then let's look back in here really quick. So we went over this. We went over PWM. Just if you don't understand PWM yet, just look. This is kind of what our servo is. Just look it up. There's a ton of documentation on it, and it's pretty easy to understand once you kind of see it. So what I try to do with these visuals, but you can look that up if you need to. Okay. I'm just gonna wait for this to finish up. And I'm gonna start doing things a little bit less, kind of like I'm doing now, because we went over stuff. I want you to start learning how to do a lot of this on your own. But I might do an electrical documentation video just to go over everything here. We'll see. I think a really cool project, like a final project, because usually after lesson 6, I kind of let you do what you want to do for the Romi. I want you to do something. I want you to take what you've learned in these lessons and put them all together. You don't have to do all of them, but put 2 or 3 of them together to do something really cool. And I think a good one would be if you move a joystick forward, it moves the servo to an angle based on which you could either do the magnitude of it or the angle that it's at. Angle requires a little bit more math, but I can show you how to do some of that if you want to. But just moving a little servo based on that would be really cool. Maybe setting up for so you can drive around the Romis with an actual joystick. That'd be kind of a cool thing. But there's a ton of different things you could work on. Even like a really cool autonomous. So I could set up a little obstacle course for you, and you just autonomously go around that. Do that. The camera thing would be a really good one. That's actually really hard though, because I haven't actually figured out how to do that. But if you could, if you have any other ideas, let me know. Getting a build failed thing here, so I don't know. We're gonna continue to see what happens. Alright everyone, I'm back. I literally just reloaded VS Code and started working, so I don't know what happened there. But we're going to simulate the robot code. And then we're going to look at the servo. So the way I have it hooked up is brown is to ground, the red is to the 5 volts, and then the yellow is to the bottom pin, which is signal. So if you want to hook it up like that, I have mine on port 6, and it's on the furthest away from the board there. Let's just make sure it works. Normal driving. Does. Okay, so I'm going to press C. Okay. And it's printing out what we said in here too. So it's servo set to 0. I might have to, here, I'll do this. Boom. Boom. Okay. So now you can see what's printing off down here and also what's happening right here. So we got C, which is 0, V, 125, B, 80. And we can click that. And as you note, like, theoretically you could hook up like 5 servos to this thing. But servos take a surprising amount of power to actually do. So if you click the button too fast, the Romi will yell at you. So if I start spamming, it starts beeping, and it does not like that much power being drawn from the pins. But that's how you do a servo, and it'd be really cool to see someone hook up a controller, or even you could simulate like the simulated joystick from the keyboard that you use to move it around or move the Romi around, just to move the servo with that. That'd be a cool project. So I hope this was helpful. Ask me if you have any questions, and good luck. This is a fun one.